We'll proceed in pseudo calculus problems. Okay, so we have taken the example of breaking the stick and finding the average length of the largest portion when we break the stick. Okay, I believe this is all right. This is what we have done. Okay, so this is what we have done. Breaking the stick into two parts and take means retain the longer part and then calculate the average length of longer part. Anyway, any discussion we are taking, we will take many examples in tedious calculus, in multivariable calculus. Okay, in that fashion, the concept is same. How to bring a normal mathematical problem into integral calculus, differential calculus. That's it. If there is a normal like capacitor charging, inductor charging. Okay, resistance capacitor inductor circuit. Consider there is a circuit where there is a voltage source. Consider there is a circuit and there is a voltage source. Makes sense? There is a voltage source and voltage so through voltage source we have connected one resistor, then capacitor, then inductor and back to the voltage source. There is a voltage source and through voltage source we have connected a wire from positive side and then it is connected to a resistance and then a capacitance and then inductor and back to the voltage source. Any moment what will be the current through the circuit, that is under question mark. If I see resistance, if anyone apply a voltage across resistance, then there will be current, and current and voltage relationship is linear relationship. Voltage applied across the current across the resistor, then if V voltage is applied across the resistor R, current that is flowing through resistor is V by R. Similarly, in the capacitor, if V voltage is applied across the capacitor, or V voltage is if this is capacitor and this is voltage source, if voltage source is applied across the capacitor, then capacitor will start charging, means voltage will be zero at the beginning, and it will take time to come to a voltage level of the voltage supply. In that fashion, voltage across the capacitor at any moment, voltage across capacitor at any moment equal to charge that is stored at the capacitor at that time by capacitance. Okay, that is, I believe, that is voltage equal to Q by C. This is what I remember. I am not sure about it. Q by C. This is what I remember. Q by C. If capacitance is more, means dV by dt, change in voltage across the capacitor, what I see is 1 by C dq by dt. That is the current. Means change in voltage means current that is flowing through capacitor at any moment equal to capacitance into dV by dt. At what rate dV by dt is changing? Or we can say if I current is flowing through capacitors at any moment, then change in voltage at that moment is I by C. If C is very high, capacitance is very high, then change in voltage we will see less. Means here we came to differential calculus. But people would say we are not that depth in differential calculus. Like voltage equal to, I'm sorry, current across across resistor is voltage by R. I understand. What about capacitor? At any moment, voltage across capacitor equal to charge that is stored on the plate of capacitor divided by the capacitance. If capacitance is very high, then whatever charge is there, with that charge voltage will be at that moment it will be less. If capacitance, if same charge we let store at the plate of capacitance, same amount of charge, and capacitance is less, then it will it will show high voltage. If capacitance is very high and same amount of charge if I place on the plate, it will be like a very small for the capacitor, then it will develop less voltage. Okay, any if I try to see what is current that is flowing across capacitor, what is the current flowing across the capacitor is that per unit time, I'm sorry, I'll rephrase it. Voltage equal to charge by capacitance. Means any moment, if I see voltage across capacitor, is what is the charge that is stored across the plate of capacitor divided by the capacitor. Capacitance is constant. More or less, voltage developed across the plate of capacitor is directly proportional to the charge it has, the net charge it has. Now, what is the charge that is getting stored per unit time? If I add 1 unit time, if I add 1 unit of time, how many charge I can expect at in that 1 unit of time will get added on the capacitor? Q by T. Q by T is the division. Means per unit time, how much is the charge? Means if I am at any time T and after that if I add 1 second, then how much charge will be get added at that time? Q by T. So if I say voltage by, now if I divide T on both sides, voltage by time equal to 1 by C into charge by time. Per unit time, if I add 1 unit of time, how much voltage will get added? Equal to, how, if I add 1 unit time, how much charge is getting added? Q by T. 1 by C into Q by T equal to V by T. But this is not linear. Means charge is dependent upon time. It is not that straightforward. I mean, relationship between charge and time is non-linear. Non-linear in a way that it is polynomial. In that fashion, this will get converted into differential equation. The way we have said, if in division numerator is dependent upon denominator, then better convert into differential. So dV by dt equal to 1 by C into dq by dt. dq by dt means per unit change in time. Earlier, per unit time, how much is the charge? Per unit change in the time, how much change in current charge we see? dV by dt equal to current by C. Current at any moment is dV by dt into C. Means how much voltage is changing at that moment into capacitor. For resistance, current at any time is voltage at that time across the resistor by resistance, where here the current is 1 by capacitance into how much voltage is changing per unit time. So this has come as differential equation. What about the inductor? How much is the current? Voltage across inductor is considered as, I believe, L 1 by L di by dt. This is what I remember. Okay, 1 by 1 by L di by dt. I'm not sure about it. But voltage equal to 1 by L di by dt, if I say voltage equal to 1 by L di by dt, means voltage earlier the current in capacitance current was in function of dV by dt. Here voltage is in function of di by dt. Because inductor is a coil. If I make copper coil round like this many times, then if I place a voltage across this, then it will develop an electromagnetic field and it will oppose flow of current immediately. If I take some iron, raw iron, and then on raw iron if I bind a copper wire like this in round shape and then apply voltage across it, then it will oppose flow of the currents like capacitor opposes rise in the voltage. That is the nature of capacitor. It will oppose rise in the voltage immediately. Like that, inductor will oppose rise in the current. In that sense, there will be di by dt. How much current is rising per unit time? 1 by L. If inductor is very high, I believe, I'm sorry, it will be, I believe it will be something like current equal to 1 by L into voltage, something like that. I'm not sure about it. Okay, but whatever the voltage at any moment is, I believe it is other way. Voltage at any moment is 1 by L di by dt. If L is large, means inductance is very large, then depending upon the di by dt, that much less amount of voltage someone can see. If L is very less, then based upon di by dt, voltage drop will be higher, whatever it is. This is the equation. Now, if someone is trying to find how much current is flowing in the LCR circuit, current will be same across resistance, capacitors and inductor because they are in series. How much they are. Now in that fashion, if someone is calculating, then current will be that if someone how someone can find the current. Okay, or if someone okay, let's proceed. If I say if I say current across resistor, then it is R V by R. Current across capacitor, then it is C dV by dt. C dV by dt. Or voltage across resistor, if I say, then it is I into R. Voltage across capacitor. Voltage across capacitor, if I say, then it will be 1 by C di by dt. I'm sorry, voltage across capacitor, if I calculate, then it will be 1 by C Q. Q is integration of I dt. I current is dq by dt, means voltage across capacitor is 1 by C integration I dt. Voltage across inductor is 1 by L di by dt. Net, if I add all three voltage, it will be equal to the voltage source, that is Vs. So Vs equal to I into R plus 1 by C integration of I dt plus 1 by L 1 by L, okay, and then di by dt. This will be the equation. If I differentiate, it becomes 0 because voltage source is considered it is DC, then it is 0. Now we have R di by dt plus 1 by Ci, differentiation of integration is I only, plus 1 by L d2I by dt square. Someone has to solve it. Okay. If someone solve it, what need to be solved? I'm sorry, 1 by Ci plus R di by dt plus 1 by L d2I by dt square equal to 0. Now, if someone solves it, then he will get the solution. Anyway, for inductor, we came to the differentiation directly, and then that will be something. Or here we can replace voltage across capacitor V equal to Q by C. Q is nothing but current into time. Current, if passing for some time, if I multiply current into time, it will give the net charge deposited at the circuit. Current into time became integral if I multiply two items. So let's rephrase it. Okay, voltage across inductor is nothing but 1 by L. And how much is the current per unit time? So voltage across inductor is 1 by L I by T. Whereas, so we will rephrase it. The voltage across resistor at any moment is I into R. Voltage across capacitor at any moment is 1 by C into Q. That is I into T. So 1 by C into I into T. That will come, that will, okay, and voltage across inductor is 1 by L I by T. If I add all three voltages, it will become voltage of the voltage source. Vs equal to I into R plus 1 by C I into T plus 1 by L I by T. Now, if I see I into T, where I is function over time, I vary at depending upon the time. I is not constant over the time. Okay, neither it has a linear relationship with the time. I varies with the time. If I have two multiplication, and one is dependent upon another, and this is independent, like time is independent and current is dependent upon the time. If I multiply I into time, I have to change into I dt integration. Okay, in that fashion, voltage across capacitor becomes 1 by C integration I dt. Similarly, voltage across inductor, that is L into I by T. Numerator is dependent upon time and time is variable independent component. I by T becomes di by dt. Net become I into R plus 1 by C integration I dt plus L di by dt if I equal to Vs. If I differentiate again, or someone has to solve it, whatever it is. Whenever we see problem and there is multiplication, then we come to integral calculus. When there is division, then we come to differential calculus. This is what we have learned. Third thing we are learning, that another way to solve any problem is to bisect the problem into many sections. If I do bisection of the cutting the problem into many sections, and we try to get the solution of all the sections and add it, it becomes the integral calculus again. Repeated summation can become integral calculus again. This is what the third thing that we are bringing into the picture. Multiplication becomes integration, division becomes differentiation, repeated as addition like summation I equal to 1 to n where n tends to infinity and ith section. If this kind of repeated section addition we see, we can come to integral calculus again. Okay, that is the concept that we are pursuing. In that fashion, we computed the average length of a stick where we have innumerous number of a stick of unit length, and in that fashion I broke the stick at any point of the stick, any point, and took the larger section and keep it. If I break before the middle, then second half I have to keep it. If I break after the middle, then first half I have to keep it. If I assemble all the larger section one by one by to infinite, then what is the average length of the stick? What is the average length of the stick that I have kept here? That we saw, and it is repeated addition again. Repeated addition means if I take any stick, then what is the length of that stick? Now I have to add for everything, and repeated addition become integration. What is the basics of repeated addition? That I'll repeat it again. Then we will see a little bit about area of circle again. So what is the basics of repeated addition that we are pursuing? Okay, what is basics of repeated addition? So basic of repeated addition is like if I take x-axis and this is origin and this is alpha, x-axis is proceeding like this. If this is 0 comma 0 origin, this is alpha, x-axis is proceeding like this. This is y-axis. If this is x-axis, this is y-axis. If this is y-axis and this is x-axis, on x-axis I have 0 to alpha. Okay, now in some computation I need to divide this 0 to alpha into n parts, and each part has a length of delta x, delta x1, delta x2, delta xi, delta xn. Okay, then what is addition of these three all? Then sigma sign I equal to 1 to n delta xi, where all delta x may be different, but all together all delta xi sum it to alpha only. Anyway, if I have this kind of situation, then blindly I convert into integration dx. X is 0 to alpha because they are going from 0 to alpha only. I have divided into n part. That is the one scenario we saw. Okay, another scenario is consider that I have 0 to alpha and I have divided into n sections. Each section has a vertical bar. Each section has a vertical bar. And this vertical bar, if I see the vertical bar, they are in function of x only. At that moment, what is the x value on the x-axis? That is fx. But fx vertical bar are in n number between 0 to alpha. If I add all the vertical bar, then it becomes repeat summation sigma sign I equal to 1 to n fx at x equal to xi. That is addition of all the vertical bar. Those are n in number between 0 to alpha because I have divided into n section. Okay, can it be written as fx dx integration sign? If yes, then y. If no, then y. Two arena we have taken. One arena is I divided this 0. These are very priceless discussion. It is not available in any of the book. One discussion is 0 to alpha are divided into n section, and each section has a length of delta x, delta xi, and they may not be the same. In that fashion, summation of delta xi I equal to 1 to n is what? Can I bring into dx integration x is 0 to alpha. One is I divide 0 to alpha into n section again, and each section has a height, that is y. fx function over x. Now I write summation I equal to 1 to n where n tends to infinity or whatever it is. N is not equal to alpha. That is the main thing. N equal to n is anything. Fx I f function bracket x and bottom right that is subscript I or fx at x equal to I x equal to ith section. I'm sorry, x for the ith section. That will be x equal to I by n. That will be the actual length. Ith section or fxi. Now this summation I can write as integration x equal to 0 to alpha fx dx. Can I write like this? Okay. If not, then why not? If yes, then why yes? Okay. Let's take the first example again. 0 to alpha I divided into the n section. Now I'm trying that it is delta x. Summation I equal to 1 to n delta xi. Now delta xi, can I write as dx integration x is 0 to alpha, not to n. What is integration? Integration is calculation of the area. Calculation of the area. And it must be in a phase of fx dx, integration x from one to another location in single variable. In multivariate fxy, function over x and y dx dy, or rather dxy plane, means we can think that everything is single variable only. If someone is saying x-axis and y-axis together, then rather than saying dx dy, I can say dxy plane. On dxy plane, what is the height? That is function over x and y. People write function over x comma y dx dy, that but better word is function over x comma y, that is z, into dxy plane. On xy plane, how things are varying into two-dimensional way, and then z, or that is the three-dimension. Two-dimension we have fx dx or y dx. Three-dimension z dxy plane. Four-dimension, the dimension will be density. Density dxyz, that will give the weight z z dxy, density dxyz, that will give the weight z, that is the height, z dxy plane will give the volume, y dx will give the area. Makes sense? This is means integration means there are two components in the integration. One is function over independent variable and another is independent variable. That's it. Integral calculus means multiplication of two items. One is a dependent item and one is independent item. Multiplication sign. Multiplication operator works on two operand. One operand is a function over the second operand. If that is the scenario, it is the integral calculus. What integral calculus does is, since it is multiplication of two items, it calculates the area. Okay, what about three dimensions? It calculates the area. What about four dimensions? It calculates the area. What is your area? Okay, now consider I have two multiplication. One multiplication is z, that is the height, and another item in multiplication is xy plane. On xy plane, I have area. XY plane, I have area, and z is the height. If I multiply height by area, it gives the area in a term that it will give the volume. Height into area will give the volume. Whatever it comes. If I am multiplying two items and one is dependent upon another, then it gives the net result z into xy plane. Since height is dependent, height is not constant. Height is dependent upon xy plane. Z into xy plane, z into xy plane, I can write as z into dxy plane. Integration xy plane from one point to another point. Okay, if I am saying I need to calculate weight where I have density of the cube, there is a cube, and density of the cube is different at different location. Different location means x, y, z, z. What is the weight of the cube? Then density into the volume. If I multiply volume by the density, it will give the weight. Density into volume. Okay, if density is variable at different volume point, it is different. Like height at different xy plane height is different. Then we calculate volume. If density at different volume points is different, then when we're calculating weight, then density into volume is the weight, where density is function over xyz coordinate because it is different at different xyz coordinate. Density into d of xyz. Okay, that is the integration. If I want to convert summation I equal to 1 to n delta xi, that is what we have taken example, 0 to alpha divided into n part, each part is delta xi. Now I equal to 1 to n delta xi if I want to sum, and then this summation I want to bring into integration calculus, then there has to be multiplication of two items. Then only it will get converted into, generally people are right in the book. Summation I equal to 1 to 1 delta xi equal to dx, x is 0 to alpha. Well, this is d, integration dx, integration of dx is x, all are fake things. Integration always need two items. Integration never happens with three item or four item. It always happens with two item only. If I convert into delta xi summation I equal to 1 to n into integration dx, then where is your fx? Fx is required. Then fx, hidden fx is 1. Actually, the full terminology integration sign 1 into dx, where fx is 1. How I converted integration is area of one item into another. Integration a, one item is xyz volume and another item is density. Then density into xyz volume will give the area, and that is the weight. If the x-axis is xy plane and another multiplication item is the height, it will calculate area again, and that area will give the volume. If the x-axis is x itself and the another one of height is the whatever it is, if I calculate the integration, it will give the actual area what we understand in reality. So if I say integration I equal to 1 to n delta xi, and I want to convert into, this is the summation, I want to convert into integration, there has one multiplication of two items. Okay, I understand, I understand. Summation I equal to 1 to n, 1 into delta xi. Makes sense? Now I have multiplication of 1 and delta xi. That is something like, if this is delta xi, then 1 is the height. This is the area of this section. If I'm dividing this x-axis 0 to alpha into so many delta x, then each delta x is now reformed into a, rather than section on x-axis, now it is section in two dimensions. This is one section because I multiplied by 1. 1 is the height and this is the width. Ith section delta x is now 1 into delta xi. Indirectly, we are summing the different area between this and this. Okay, if I add different area, then it gives the full area from here to here. No, 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 no. Idea is that I am dividing it into different section in one dimension only. And idea is to calculate the addition. That is same as if you add the area where height is 1. Same. But if it comes to section of area, and if I add all the area, indirectly we are calculating the full area. Full area where this is x-axis and height is dependent upon x, that is fx. Then I can actually transform into fx dx. In that fashion, summation I equal to 1 to n 1 into delta xi will give the area of the ith section where height is 1. If I keep adding all the section, it will give the full area. Now I can write integration of x equal to 0 to alpha, because x is going 0 to alpha 1. 1 into dx means function over x is 1, that is constant, into dx, that it can transform like this. Another scenario what we are seeing is I divide 0 to alpha into n section, and in each section I have one vertical bar. Y is there. Earlier x was there, y was missing, and here these are not available in any of the book. Now y is there but x is missing. Now I sum it. Summation I equal to 1 to n. Summation I equal to 1 to n, and then fx at x equal to fx or fxi function over xi at the ith location. Okay, every location we have different x, but in one section I've divided into n section. In one section, one bar chart will be there, one height will be there. Summation I equal to 1 to n summation sigma f x I. This is the summation. Can it be converted into integral calculus? Okay, to convert into integral calculus, again we need height into width. That is the required. We only have the height, not the width. Okay, we can try now. What is the width? Consider the width is 1. Summation I equal to 1 to n fxi multiply by 1, hidden 1, right? But that will not work. If I multiply by 1, then I need 1 of the gap. Now if this is fxi, if I multiply by 1, then 1 is the gap, but gap is not 1. If I divide 0 to alpha into n part, each part has gap of alpha by n, not 1. If I deliberately say 1 is the gap, then we are saying false thing now. So I cannot rewrite summation I equal to 1 to n fxi as summation I equal to 1 to n fxi into 1, where 1 is the width. Okay, mathematically it is true, but it will not work here in this fashion. That is not true. In that fashion, what I need to do? Consider that n is same as alpha. Number of n, divide chop this x-axis 0 to alpha into n section, where n is alpha only. Now I can write multiply by n. If I divide 0 to alpha into alpha part only, 1 will have width of 1 only. In that section, summation of I equal to n, where n is alpha, fxi can be written as summation of I equal to 1 to alpha fxi into 1, because anyway width is 1. If width is 1, then I can write like this. In that fashion, I can go ahead with the integration. X is 0 to alpha fx, whatever fx we did, dx. Makes sense, because if I add all 1, then it becomes alpha only. But if n is not equal to alpha, summation of I equal to 1 to n, where n is not equal to alpha, much more than that, less than whatever it is not equal to alpha. It maybe tends to infinity. If I add all fxi, if n is 100 between 0 to alpha, where alpha is less than 10, then a 100 summation of fxi will be very big than calculation of the area. Okay, how it will be big? Because if I calculate, anyone can think about it. If I calculate what is the summation between 0 to alpha, that if I sample into alpha part, then it is fx dx. Then it is fx dx x equal to 0 to alpha, or summation I equal to 1 to alpha fx fxi is same as fx dx. Now I can bring into integral calculus, and certainly summation of I equal to 1 to n fxi is not equal to summation of I equal to 1 to alpha fxi. Summation I equal to 1 to alpha fxi can be brought into fx dx, x is 0 to alpha. Since they are not same, this cannot be brought into integral calculus. How we can bring into integral calculus? If you want to bring into integral calculus, then whatever fx you have, there is a bar called fx, function over x, at any moment. If I connect all the top part of this fx, it will give me the actual fx, like fx equal to 1 by x, or fx equal to x, fx equal to sin s, fx equal to x square. If I connect all the vertical points, it gives the actual fx. If it gives the actual fx, then fx dx calculate the area underneath it. More or less, if I have chopped 0 to alpha into n part, and one part of area if I calculate and add all the area, then I can convert into fx dx with summation of I equal to 1 to n fxi. If I convert into fxi into delta xi, that where delta x is alpha by n, if they all are same, if all widths are same, then it can be converted into integral calculus. What I'm trying to say, I have to modify fx now. The fx what we have calculated, that should be modified so that fx will be dx delta xi. Delta xi is the gap between two vertical bars, or the width, that if I divide into n section, what is the width we have got? Means more or less we are saying that, more or less we are saying summation of I equal to 1 to n fxi equal to summation of I equal to 1 to n gxi into delta xi, where delta xi is the width between each part, that is alpha by n. If I'm able to get gx, that is modified version of fx, then I have now again writing same thing as alpha I summation I equal to 1 to n gxi delta xi. Gxi is another function in the ith section, where that is the height and delta xi is the width. That is the area of one section in the all the area. If I add like that, it becomes the complete area between 0 to alpha, that is 0. X is 0 to alpha gx dx. If I'm able to succeed in that, then that will come as integral calculus. This is how we transform the normal repeated addition to integral calculus. Anyway, then we had seen the average length. If I'm trying to calculate average length of a stick or something like that, then there we saw probability function. Probability function means, like, if there are students in the class, there are 10 students in the class, and they secure marks. Mark is between 0 to 100, and we divide into one part, distance of 1 unit. If I divide into 100 parts, then 50th part, that is the 50 marks, number of students are 4 by 10. That is called probability mass function. How much the student are? That is 4 by 10, because that is the probability of students. 4 students out of 10 students, they have got 50. 4 by 10. Okay, consider in a class, 4 students got 50 marks. 2 students got 40 marks, 60 students, 3 students got 60 marks, and 1 student got 70 marks. In that fashion, if I have 0 to 100, at 50, I have a bar that is height as 4 by 10, at 60 3 by 10, and 71 by 10, and 42 by 10. I am calculating average marks of the student. Average marks means what is the average in this distance. This is the marks axis, and this is the probability axis. 4 by 10, 2 by 10, 3 by 10, 1 by 10. What is the average mark? Not average probability we are checking, average mark. If I'm trying to calculate average mark, then it will be x distance into the height plus x distance into the height plus x distance into the height plus x distance into the height. How much it is? Then it is, I can write summation I equal to 1 to 4, because there are 4 only, or I equal to 1 to 100, because 100 section I have made, and then the distance, that is xi. If I take any ith section here, that is 100 sections we have divided. If I take ith section, then xi fxi is the probability mass function, that is the height. Okay, then for x equal to 1, there is no height, 0. All are 0, only 4 will remain. I equal to 1 to 100, now there is summation of 4 only. That is, x is 40, then height is 2 by 4. 40 into 2 by 4 plus 50 into 4 by, I'm sorry, 40 into 4 by 10 plus 50 into 40 into 2 by 10 plus 50 into 4 by 10 plus 60 into 3 by 10 plus 70 into 1 by 10 plus all 0. Okay, can I convert this summation I equal to 1 to n x fx xi fxi into integral calculus? Certainly, we can convert into integral calculus, because we have done a chopping of one length only. So everything I write xi fxi, I can multiply by one hidden one also, because section is one, all section width is one only. In that fashion, one I can rewrite as delta xi, where delta xi tends to is 1. There is no problem here. Summation I equal to 1 to 100 xi fxi into delta xi, where delta xi is 1. Now it can be returned as x fx dx. X is 0 to 100, but fx someone has to find out. What about if I say summation of I, if I, there are marks that is 0 to 100, marks 0 to 100, and student can get anything, not in the 1 mark. I can divide this 0 to 100 into n part, where n can be infinite also. Someone is getting marks as 50.1, someone is getting marks as 50.2, anything someone can get. Summation of I equal to 1, to n xi fxi, where n tends to infinity and it is between 0 to 100. Can I bring into integral calculus? Certainly not, because there are so many chopping we have done. We are expected to do 100 chopping only. In that case, we have to bring another function gx. Okay, in that term, gx in x fx dx f summation I equal to 1 to n x fx or xi fxi should become equal to summation of I equal to n gxi delta xi. In that fashion, I have to find gxi equal to x fx by delta x, where delta x is 100 by n, because we divide into n section. 100 by n is the width of one section. Now, if I'm able to find gx in this fashion, these are trillion dollar explanations. These are not available in the book. Summation I equal to 1 to n, summation I equal to 1 to n, and then xi fxi equal to summation of I equal to 1 to n gxi delta xi, where gxi equal to x fx by delta xi. If I am able to find that gx, then it can be turned into integral calculus. Integration x to integration of x is 0 to 100 gx dx. This is repeated addition to integral calculus. Okay, we have in the past video we took the probability density function also. If I rather than chopping 0 to 100 or 0 to 1, probability generally it happens from the 0 to 1. Then typically this is what we take. We can take 0 to 100 also. If I divide our marks as 0 to 100 and then I draw a probability function, that probability function is continuous. That is gx we are talking about. X fx summation I equal to 1 to n fx, we have chopped into n part and each part I have fx, but it is discrete manner. But gx what we have taken, because we are bringing gx into integration gx dx, gx should be considered as continuous function. Altogether, if I start our discussion, that if I have x axis and there is a continuous function, then what will be continuous to discrete? Makes sense? We started x fx summation I equal to 1 to n summation I equal to 1 to n gx d delta xi, where gx is the continuous function. Gx equal to x fx by delta xi. How to get again back fx from gx? I got gx from fx and repeated summation I renamed into integral calculus. If I have integral calculus expression, like if I have gx that is continuous function, then how I can bring back fx now that is discrete one. If I have a continuous function as gx and that is a probability density, this is called probability density function. If I have x fx I fx xi fxi summation I equal to 1 to n, this fxi is called density, is called probability mass function, because every section of I, if I divide any line into n section, every section I have one probability bar. In 50.5 marks, how many students are there out of 10 students or out of 100 students, whatever it is? That is called probability mass function. But if I draw a continuous chart against the marks chart, that is called probability density function. That is continuous function. That is what gx we are talking. How we get gx from the fx? We gave the formula. How to get back fx from gx, that is a discrete bar again? Then what is the density function of the probability? If I have density function of probability gx, then gx dx between from 0 to 100 will give the 1, because net probability, if I have a density function, always I have said, if vertical is density and horizontal is density is upon what? If density is upon the marks, then if I multiply this, I'll get the weight. The weight of the net probability is 1. If I have the area, if I have a density probability function, if I multiply by this, that is gx dx, or gx into x, that is gx dx, the net integration over lower limit to higher limit should be 1. What is your 1? Like example, we are giving that at 40 marks, number of students are 2 by 10. 50 marks, number of students are 4 by 10. Here 3 by 10 and 1 by 10. Consider similar fashion. If I add all, then it gives 1. Net probability must be 1. If I add all the outcomes, these are the outcomes. All the outcome, if I add, it becomes sample space, and that probability is 1. If I have graph of gx, how I can get back gx, how I can get back fx. Fx means at between 50 to 51, I will have a bar of 4 by 10. Between 60 to 61, I have bar of 3 by 10. Integrate your gx over that region and you get the fx. Makes sense? Fx, I just taking out x now. Fx equal to gx dx. Dx equal to fx by dx. Makes sense? Dx equal to fx by delta x. This is how we get gx. Then fx equal to gx dx. How I get back our discrete form is gx dx, what it is. Like we gave example that if I cut a stick, then probability of getting the probability, if I draw the continuous probability graph over the stick cutting, it is 1. Please watch our previous two videos. If I divide into n section, each section probability is 1 by n. 1 by n. Then fx is 1 by n. Fx equal to gx delta xi. Delta xi is 1 by n. dx will be 1. In that section, we have continuous probability graph as 1. If I want for the one section, like for the student, someone has to find gx. That gx, if I integrate over like this, like for the stick example, please go back to and see our stick example. For each, if I divide a stick that is 0 to 1 length into n parts, each part is 1 by n width, where probability bar is 1 by n. Width is 1 by n, it is also 1 by n. If I want continuous chart, then that is 1 that we saw. If I want to see what is the probability bar for the section this, then I have to integrate gx dx from one location to another location. That is from the ith section to I plus 1 section. Okay, in that fashion, 1 dx, gx, that is continuous probability is 1. 1 dx from the I section to I plus 1 section. Ith section is I by n, I plus section, the length from here is I plus 1 by n. It will come as 1 by n. Means if I take a gap of 1 by n, then for a bar is 1 by n. What about if I take gap of 10 by n? Then what will be? I believe it is understandable. If there is a stick of length 0 to 1 and I divide into n section, then and if I make a random cut, what is probability that I will cut into any one of the sections? Since there are n number of sections, probability to cut in a particular section is 1 by n. Okay, that is discrete. Everywhere it is 1 by n. Out of all n section, everywhere it is 1 by n. Okay, that is n number of bar we are seeing, everyone is 1 by n. But this is discrete. If I talk about the continuous function, then it is 1, not 1 by n. If I want continuous to discrete back, I have to integrate this back to, because gx dx equal to fx, where fx is discrete and dx is continuous. Gx equal to fx by dx, dfx by dx. If I want to get back fx, that is the discrete one, fx equal to gx dx back. If gx is 1, then 1 integration 1 into dx from ith section to I plus 1. No, I want for 10 section. For 10 section, give me only 1 bar. Okay, understandable, right? If I have n section, for each section probability bar is 1 by n. For 10 section, I want 1 probability bar only. Then first convert into continuous function, that is 1 dx from I to I plus 10 by n. I by n, that is the length here. From here to here, if it is ith section, length is I by n. One section is 1 by n. I by n to I plus 10 bracket by n. That is the for length 1 bar I want. These are priceless discussion. In that fashion, it would become I by n to I plus 10 by n, and then fx dx, gx dx, that is the continuous dx, I by n to I plus 1 by n. So it will become I plus 10 by n, I by n plus 10 by n minus lower with I by 10 by n. 10 by n will be the height of a bar if I take all 10 sections into the consideration. This way, we can convert discrete into continuous, continuous into discrete. Anyway, actually, idea was here today to proceed in the area calculation of the circle again. If I have area of the circle, then if someone remembers, then we chopped into n number of parts to calculate the area or circumference. If I have area of circle and this is x-axis, this is y-axis, then then this is origin. Then I move a radius like this and chop the circle into n number of parts, where one is the one side of this circle is, if this is the x-axis and this is the radius starts moving like this. First section, second section, third section, ith section. Okay, if I get the ith section, then I can write like this: the area of the circle is summation I equal to 1 to n area of the ith section. If I add all the area, I get the. Now this I will proceed again, and then we will see very miracle here, and that how we can do with the repeated summation. First we tried with the normally calculating the area of the ith section. Then we tried vector. In vector we will do many kind of bumps here, that we will see. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. Now people understood that if I have continuous function, and then if I integrate from 0 to n, then I should get 1. That is the requirement, because probability is net is 1. Then integration I by n to I plus means 0 to 0 to 1. That is the full. I is the 0th section, and I plus whatever we are saying, that is the last section. If I talk about the length 0 to 1, fx dx 1 dx x 0 to 1 1. Net probability come. If I have a stick of length 1 and I divide into n section, but for all n section I want one bar chart only, that will be at the end. What will be the height of the bar chart? Of the bar, then it will be 1. If I want 2 bar, one at the middle, 1 bar, and at the end of this, then what will be the height? Or if I divide into n section, and at every section I want bar, what will be the height? Every section it will be 1 by n. At the end, if I want, then it will be 1. If I want at the middle one and at the end one, then someone can integrate like this. Okay, do not mind supporting us. Do not mind supporting us. +91 India country code 9483160610.